We are going to address here a topic already introduced before, which is the ICT technologies and how ICT technologies helps actually the railways, and particularly the railways in the GCC. So first question, what is ICT? ICT comes from the first information and technologies, information technologies. So that's basically the computers, networks, hardware, whatever it's hardware or software. And then communication. When we say communication here, we are referring to use of telephones, whatever it's wireless or fixed telephones. It's also about audiovisual content. So that's the communication part. So everything is covered by ICT, this terminology. So ICT can be helpful to our railways. And this is how we are going, what we are going to discover during this presentation. So how ICT technologies can help the railways. And in our context, how innovative ICT helps the GCC railways. Because as far as Huawei is concerned, we are focused on innovations, innovative technologies. And we are here in the GCC to address the specific challenges of the region. So we are going to address first the challenges and to show you our capability as an ICT provider. So first, let's take a look quickly at the main challenges we think are here in these regions for the railway market and railway industry. So one first challenge, during the operations, during the live network, when the trains is running or the metro is running here, how to share the information between the people, the staff on board, and the tower that control the dispatching system in real time. So that's one challenge. How to reduce what we call the distance in terms of exchange and to make them more interactive between the railway employees in order to increase the efficiency. So that's the first challenge that has to be addressed generally by the railways and particularly in the GCC. Another challenge in case of emergency, how to ensure that there is a good, smooth communication between the people, particularly in case of emergency when an unlikely event like a crash happens. How to make sure that the people communicate to each other in order to make this resolution of such a bad event in a good time. So that's a big challenge. Of course, it's not like in this picture, but with the new technologies that we can bring in the 21st century. Thanks. So another challenge now about the critical applications. So we have a list here of at least 3 critical applications, like the train control signaling, which is here to control the trains, the drivers, the speed, and it's like a red light for the car traffic, same concept. Also, when you have to care about some sensitive locations, then you have to put some video surveillance systems. Another kind of critical railway application, when you have some long trains. In this case, most of the time there is 2 locomotives, one on the front, one at the end, and both have to be synchronized and have exactly the same speed. So how to make this kind of synchronization happening? Here, this kind of critical railway applications needs to be addressed, and we're going to see later how we can address them. Another challenge, really specific to the Middle East, to the GCC, that's indeed the environment. The conditions here, the weather, are very specific, and then, of course, all the solution you're going to implement, whatever is for the right track, the rolling stock, the trains, or even the radio telecommunication infrastructure you deploy outdoors, all this has to fit with these very extreme conditions. Another challenge very specific to the GCC is actually this very interesting project, the transnational project. So the GCC transnational railways connecting all the 6 GCC countries to each other with these trains that is starting from Kuwait and going to Oman. All this path, this trip must be, let's say, working in the same condition. So whatever the country, And whatever the company here, the challenge is to ensure reliable exchanges between the railways and to ensure also a transborder exchange. One challenge we listed for the metro earlier, but that applies also for the mainline trains. Here, how to attract and keep customers. So how to make customers more keen to travel by train and leaving their car at home. It's a particular challenge here in this region where the people are really used to take their cars. They have some very close relationship with their car. It will be for sure a big challenge to change the habits of the people and to make them prefer the trains. Last challenge identified, in Europe most of the project consists on extending and modernizing existing infrastructure. Here in the GCC we're going to start from scratch. So here we have to actually care about a strategy, a long-term strategy of investment. What technology to invest in? And that's for sure a challenge very specific to the GCC region where we create brand new systems and brand new transportation networks. So now let's go to the solutions. For the first challenge we proposed in the beginning, we presented in the beginning, one solution in terms of ICT has been developed over the last years. This solution is called GSM-R. And this solution is used for data and communication systems. So this is how the ICTs can help here on this first challenge. So basically the concept of what GSMR is to ensure reliable communications between the people working for a railway company. So here GSMR is not used by the public, but it's used by the staff. So the driver, the dispatchers, the maintenance team. So all these people need to communicate to each other during the operations. And GSMR is considered today as the most reliable communication systems. But not only. Actually, GSMR is also used to convey the signaling train control data. So very critical and very sensitive data we'll see later. Then, as I said, the critical data for the train control signaling, which are part of the ETCS level 2 standard here, together plus with GSMR, deliver highest availability for ERTMS. So the European Railway Transportation Signaling System is actually specifying GSMR as the bearer for the signaling, for the train control signaling. So GSMR then play a very important role here. We can also imagine a solution for the synchronization of the locomotives I mentioned before, based upon GSMR together with GPRS. And that's something that we particularly do Huawei in China. So in order to support also some very important data in terms of amount and volume, huge amount of data, here we need well-dimensioned and secure transmission systems. So as part of our solutions, and this is globally provided by the ICTs, we do provide this kind of transmission system which can be used to to convey the data coming from the cameras, and that are going to store on some dedicated servers. So the reliable transmission and data communication network are quite critical for railway operators. Other challenge we addressed before, this challenge regarding the condition can be resolved with dedicated equipments that are designed in such a way that they support these harsh conditions we have in the Middle East. So using this kind of equipments will be definitely important and even mandatory for the railway operators in the regions. So for the cross-border challenge here, GSMR is very useful. Actually, GSMR has been defined based on the GSM specification and the standard. And actually, when you use your GSM mobile 2G or even now the 3G or the 4G, you can roam in other countries. You can still use your mobile. The same principle apply for GSMR, and the people, the staff working, for example, for Saudi railways, once this train coming from Saudi Arabia will, in the future, go inside the UAE, the people inside the train, they can still use their GSMR mobiles and equipments and devices to be able to communicate. So GSMR here provides a solution to this very important challenge, which is the roaming between countries. Other challenge we had addressed before when we talked about metro, the same apply here for the trains. To keep the customers and to keep the passengers interested, it's very important to make the journey enjoyable. And for that, by providing such services like voice communications, internet access, video on demand, then for sure you attract customers and you persuade them to do the journey inside the train. And that's something that is very important for the railways in the future here in this country to implement, to change the habits. People most of the time are used to go from Dubai to Abu Dhabi by car. They will still do it, even if in a few years we're going to have a connection between Dubai and Abu Dhabi. So to convince those people to change and to take the train in the future, for sure, we need to provide them this kind of state-of-the-art latest applications. So the last challenge about the new concept here, how to deploy a project from the beginning. Here, it's very important that from day one, the transportation networks, whatever it's metro or railways, are well dimensioned. But not only, it's important that in terms of telecommunication infrastructure, they use the latest technologies. In order to have, let's say, a technology which can be used over the next 10 or 20 years and not to be obliged to change because of obsolescence. Technologies is going very fast, and every day we see changes. So here, the advice is to start from the very beginning to implement the latest technologies based on 4G telecommunication systems to be used inside the trains or in the railway stations. So now, how Huawei is implementing these kind of solutions. So about GSMR first. We've got a highly compact and fully geo-redundant IP core network. So you can see on this picture the GSMR network from the beginning to the end. So the beginning is what you can see, it's the antennas. We call it the BTS. And then in the upper part, you can see the core network. Those are basically computer servers that are used to control the communications. So the trains are going to be running on the right track. Those antennas are deployed all along the right track. And of course, we need those antennas to be always available. And even more, if one antenna fails, the other one will take over immediately. This is the geo-redundancy concept. It's implemented on the BTS side, so on the antenna side, but not only, it's also in the core network part. And on the top part, you can see also this redundancy put into application with this concept of duplication of the equipment called BSC, the base station controller. So if one fails, the other one can take over automatically. Last but not least, this kind of solution is based on IP. So we go, as far as Huawei is concerned, directly to the IP technologies, and we are not using the legacy TDM core network. So this dual location BSC is the feature I was just describing before. We are proud to be the first one in the industry to implement this kind of solution. Then, as I said, if one side fails, the other one will take over. Most important, this is an automatic mechanism which prevents any manual intervention. Then it's quicker to reestablish the service with this kind of automatic mechanism, and it's also safer. Finally, about our BTSs, the BTS that we provide are based on a single RAN technology that is multi-technology hardware. So we use it also for 4G LTE solutions, for 3G UMTS, as well as the legacy 2G GSM. So this GSMR system is based on this kind of solution that is coming from the wireless world for the operators that we know, ETCS and do, for example. The same kind of technology will be used for our GSMR with a lot of advantages, like a very small footprint, this geo-redundancy option, and also we can set repeaters on our BTS modes. So finally, we can say that Huawei got the most modern GSMR portfolio on the market, with a huge set of features that will fit with the needs of the railway operators, and we are basically able to use directly from now the 4G. So we have a 4G ready GSMR solution, which is the key for the new systems, railway systems implemented in the GCC. Focusing a little bit more on the core network. So those boxes you can see on the left side, on the right side, sorry, are the core network components. Most of the time in the legacy networks, they are individual boxes. In our solution, we have a 5-in-1 solution, meaning that in one single rack cabinet, you have the 5 solutions, the 5 functionalities put in place. This is unique in the GSMR market. We are quite proud of it. We developed it especially for the railway market. And since InnoTrans last year, in September, we officially announced the new release, the GSMR 5.0, which ensure the railway customers full LTE capabilities for all network elements. So our solution, as mentioned before, is fully ready for the next generation of communication. Now about the challenge about the environment, our BTSs are designed in such a way that they can be definitely deployed in the GCC. For example, in the UAE, we used for our customers ETCS and do this kind of BTSs. So the outdoor solution we do provide have been already widely deployed in the Middle East in hot desert conditions for many other wireless operators. So as far as railway is concerned now, you are going here in these countries to use the same kind of technologies widely deployed, which is highly resistant to the heat, the dust, and humidity. And any more information you would like, please go to our booth. You can have the dedicated presentation. We have also a sample of equipment that you can see. So related now to the BTS, we have also another kind of BTS, which is called a distributed BTS. This one is used particularly to be deployed in some very specific and complex railway scenarios, like tunnels, like shunting yards, like long bridge. So the distributed BTS is also unique in the market. We are quite proud to be the one who provide it. It's a very innovative solution, and it helps the railway operators to deploy their GSMR in the very complex environment and scenarios. So Huawei is not new in the market, actually. Huawei started to invest and to develop this GSMR solution in 2002 in our R&D centers. Since that time, we achieved a lot of milestones. But basically now, we are one of the most important players in the market, with more than 10,000 kilometers deployed all over the world, with all the certification with the related standard, the GSMR standard, and also a lot of other multi-vendor testing that has been done. Then we can now also highlight our readiness for the Middle East. And we are quite proud to mention that we have been awarded last year the first GSMR project in the country for Etihad Rail to cover the phase 1 project. So Etihad phase 1 is using Huawei GSMR, and we are quite proud of it. But not only in the UAE, we have many other references that I will address in the next slides. So that's to show you our IoTs and our certifications. That's our vision. So as we said, we are 4G ready. So today, our solution is dual mode GSMR LTE. So as mentioned before, with this application, we can increase the passenger satisfaction, but with LTE, we can also provide some safety-related application, such as real-time CCTV. So the real-time CCTV is here a concept that can be used in order to be proactive. Then the driver can see what's happening 3 or 4 kilometers ahead just by looking at the monitor on his onboard units. So that's done also through LTE, which will be the bearer of the CCTV informations, and that's something very important. So the 4G LTE for rail solution is definitely fit for the need of the future future railway operators in the country. Transmission system we do provide. This is something very important as well. So this transmission system, such as SDH or IP networks, are here to support all the critical applications and also the non-critical applications that the railway operators want to deploy in their network. That's a bit about metro challenges, but we have seen that before. So let's go straight now to the facts about Huawei. Huawei is a global company with more than 150,000 employees all over the world, with a lot of R&D centers and with a global presence. Particularly in the Middle East, we are serving most of the most important the most important wireless network, as well as the Etihad rail. So that's something which is very important. Our local presence makes us stronger to be able to support the railway in the future. So about our customers, we have many projects all around the world. As I mentioned, the UAE Etihad Phase 1. We have also in Turkey and Turkmenistan, Australia, Italy, and Germany GSMR projects that are currently under deployment. And of course, our Chinese market, where we've got almost half of the shares of this market. Also, other than GSMR, we have also about 40% of the Chinese transmission railway market. So to tell you about our reference in the UAE, that's the reference we've got in the UAE. We are quite proud of it. So together with Selex, the telecom subsystem integrator, we are providing our GSMR solution, and this GSMR solution is LTE ready. So that's for the conclusion.
Okay. Right, thank you very much for that. Does anyone have a particular question on that? Just one question for me. On my bit of London Overground, we have GSMR. We were the first in the UK to roll it out on a standalone basis, and it's worked well. It's not one of your systems, but it still works well as technology. We've been told there is interference between that and 4G. What are your views on that?
So our equipments are 4G ready. So meaning we took into account this interference consideration.
Okay.
And even more, our equipments are dual mode. So they support actually together GSMR and 4G. Of course, we need for each operator to make a dedicated study to see what could be the impact, because LTE can run on many different frequencies. However, we can do it, and our equipments, whatever is from the core network or from the access network, support this LTE and this GSMR technology together on the same kind of hardware. So we don't have any problem with this kind of interferences.
Okay. Thank you very much.